Hello everyone. So today we're going to go over section 5.4, translating graphs of conic sections. So once again, we'll be working with stretches, so A and 1 over B, and also translations, so the constant C and D as well. So let's look at example number 1. First thing we're going to do here is rewrite the two terms on the left-hand side. The first term can be rewritten as x minus 3 all over 5 and then all squared. The second term, we can do something very similar, and that is y minus 4 all over 2 and then all squared. And the right-hand side is going to be equal to 1. So once our equation is written in this form, it should be easy to see that the form of the conic section is x squared minus y squared equal to 1. It has undergone the following transformation. First, a horizontal stretch by 5, and also a vertical stretch by 2. Now, the conic section has also been translated 3 spaces to the right and 4 spaces up. So we can combine those two with the following statement, and that is the center of the hyperbola is now 3, 4 instead of the usual 0, 0. Okay. We can also describe the slopes of the asymptotes by writing that the asymptotes are congruent to sorry about that. Y is equal to positive or negative 2 over 5 x. Okay. With this information, we can now draw a sketch of the conic section, the hyperbola. First, we'll locate the center 3, 4. There it is. And we can label the point. Next, we'll use the slope of the asymptotes to draw those in. And also the negative one. Okay, so we can also include the equations for the asymptotes in point slope form. So that will be y minus 4 is equal to negative 2 over 5 and then x minus 3 for the negative slope line. And then for the positive slope line, we have y minus 4 once again, and then it's equal to 2 over 5 x minus 3, which tells us that the line has slope of 2 over 5 and negative 2 over 5 respectively, and that it goes through the point 3, 4, which we know it does. Okay, so to draw the actual hyperbola, note that originally the two vertices of the x squared minus y squared equals 1 hyperbola are one space to the left and one space to the right of center. Because of the horizontal stretch by 5, the two vertices will now be 5 spaces to the left and 5 spaces to the right of center respectively. So we can simply count that out. So this will be one of the vertices with coordinates -2, 4. And there will be one on the right hand side as well. However, it is off the graph, so we will not be drawing that here. From there, we can use a table of values to find additional points for this hyperbola, just to ensure that we can draw a very good graph. And of course, finally, the last step is to connect the points to draw a smooth curve, going through the vertex, in this case on the left-hand side, and approaching the asymptotes. Okay, so that's the first part of the question. It says to describe and sketch. So we described the hyperbola with the basic form, the stretches, the translations, and since it is a hyperbola, also the asymptotes. And of course, the sketch is to the right. Now, the next part of the question asks us to rewrite the equation in general form. Okay, so let's look at that part. So first step is to multiply every term by the lowest common denominator, which is in this case 100. So the first term then becomes 4x minus 3 squared. The second term becomes 25y minus 4 squared. And the right-hand side will be now 100. Again, each term is multiplied by 100. Next, we can multiply out each square. So instead of x minus 3 squared, we have x squared minus 6x plus 9. And the second square, we can also multiply that out. We will have y squared minus 8y plus 16. And that, of course, is still equal to 100 on the right-hand side. Okay, now we can multiply the 4 with every term in the trinomial. So 4x squared minus 24x plus 36 minus 25y squared plus 200y, and then minus 400. Note that in the second trinomial, we're multiplying every term by negative 25. So that's why the coefficient and constants work out the way that they do. And finally, we're going to rearrange the terms, leading with the x squared. So that will be 4x squared, followed by the y squared, so minus 25y squared. And then the x term of minus 24x, the y term of plus 200y. And finally, the three constants can be combined together and written as minus 464. The right-hand side will now just be 0. Okay, and that's it. So let's look at another example, example 1b. The first step is basically the same. We are going to rewrite this equation as y minus 3 over 2 all squared minus x minus 4 over 3 all squared, and that's going to be equal to 1 on the right-hand side. So this time, we have the y squared minus x squared equals to 1 hyperbola. There are, once again, two stretches, so the horizontal stretch this time is by 3. Note that that is the coefficient next to the x variable. And the vertical stretch will be by 2. This time the center of the hyperbola is going to be 4, 3. Okay, so again, x and then y, so x minus 4 gives us the 4, and then the y minus 3 gives us the 3. Okay, next, to write about the asymptotes, we are really just interested in the slopes, so we can just write that the slopes m is equal to plus or minus 2 over 3. Okay, so with this information, we can once again draw our hyperbola. First, we will locate the center for 3, label it. Next, we'll use the slope to draw the asymptotes. So something like this. And then on the other side, of course. Okay. Sorry about that. And this time, we will not be including the equations. We can just write it in point slope form, and that's relatively easy to do. Next are the vertices. And since this is a y squared minus x squared equal to 1 hyperbola, the two vertices will be above or below the center. Usually will be one space above and one space below. However, due to the vertical stretch by 2, there will now be 2 spaces above and 2 spaces below instead. So 1, 2, and 1, 2. So that would be 4, 5. And 4, 1 respectively. So after that, we can use once again a table of values to find additional points on our hyperbola. And the hyperbola will look something like this. So let's go ahead and connect the points with a curve going through the vertex and approaching the asymptotes on the sides. Okay, so second part of the question, we are now going to rewrite once again the equation into general form. Okay, so the first step is once again multiplied by the lowest common denominator. So in this case, that's 36. So we are going to get 9 and then y minus 3 squared minus 4 x minus 4 squared. And that's going to be equal to 36. After that, we're going to expand the square once again, just like the previous example. Okay, so minus 4x squared minus 8x plus 16 equals to 36 on the right-hand side. Okay, and then now we're going to distribute. So 9y squared minus 54y plus 81 minus 4x squared plus 32x minus 64 is going to be equal to 36. And once again, we're going to rearrange the terms, so leading with the x squared, so negative 4x squared plus 9y squared plus 32x minus 54y. And finally, the constants combine to make negative 19, sorry, or minus 19, and the right-hand side will simply be 0. And that will be the general form of this particular hyperbola. So the next kind of question we're looking at is going from general form to standard form and then being able to draw that conic. So let's look at the next page. So about the general form, it will look like this right here. So that is ax squared plus cy squared plus dx plus ey plus f equals 0. Now, if both a and c are both 0, we are simply left with some kind of a linear relation. So at least one of a or c is not 0. So from there, we can graph the equation. If it does exist, then it is going to be a conic section of some kind. If the conic section is an ellipse, then the product of a times c will be greater than 0. If it is a hyperbola, then the product will be less than 0. And finally, if the conic section is a parabola, then either a or c is 0. Okay. So let's look at how we can rewrite equations to allow us to graph them. It requires the skill completing the square. We're going to rearrange first the terms so that the x terms are next to each other. So 4x squared plus 32x. And then 2y terms minus 9y squared plus 18y. And finally plus 91 is going to be equal to 0. Next, we are going to factor out just the coefficient in front of the squares. So we have 4x squared plus 8x, and then minus 9 in parentheses, then y squared minus 2y, and still plus 91. That does not change. Okay. Next, we are going to divide the coefficient in front of the x by 2, so we get 4, and then we'll square it and add it to the terms inside the parentheses. And we'll do the same thing with the y squared as well. So 2 divided by 2 is 1. 1 squared, of course, is still 1. Let's add it here, plus 1. And then plus 91. And just as we saw before with completing the square question, if we added 16 and 1, we also have to subtract their equivalent. So since the coefficient outside the trinomial now is 4, we're not actually adding 16, we're adding 16 times 4, which is 64. And in order to balance this equation, we have to subtract 64. And likewise with the 1 here, we're adding 1, but then we're going to multiply it by negative 9. So we're actually subtracting 9. So we have to add 9 in the equation. So the right-hand side is still going to be 0. So from there, the first trinomial is now a perfect square. We can rewrite it as x plus 4 squared. The second trinomial is also a perfect square. It will be y minus 1 squared. And now we can also combine the constants and get plus 36. So from there, we're going to move these two terms to the right-hand side of the equation and then kind of rewrite everything. So we're going to get 36 is equal to 9 and then y minus 1 squared minus 4 and then x plus 4 squared. Okay, now we can simply divide both sides by 36. So 1 is equal to y minus 1 squared over 4 and minus x plus 4 squared all over 9. Now we're going to factor these two terms on the right-hand side and also rewrite them on the left-hand side. So we're going to flip the equation around so that it is more familiar. So we get y minus 1, sorry, over 2 all squared minus x plus 4 all over 3 all squared, and it's going to be equal to 1 now on the right-hand side. So just as the examples in the previous page, we now have all the information that we need in order to graph this conic. So there is the first piece of information, and that is the general shape. It's going to be a y squared minus x squared equals to 1 hyperbola that we're graphing. The two stretches, horizontal stretch by a factor of 3, vertical stretch by a factor of 2. The center is going to be negative 4, positive 1. And then the slope of the asymptotes, so m, is going to be equal to plus or minus 2 over 3, based on what we saw with the horizontal and vertical stretch. Okay, so with all that information, now we can go ahead and first start by drawing the center, which is going to be negative 4, positive 1, so right here. Next are the two asymptotes. So again, 2 over 3 is the slope. Let's go ahead and draw those in. Likewise on the other side as well. Okay, so once that's done, we can now look at the type of hyperbola that it is, and we'll note that the two vertices are above or below the center. And in this case, because of the vertical stretch, it's going to be 2 spaces above or 2 spaces below the center. So let's draw those in. Okay. And finally, once again, we can use a table of values to find additional points to draw. So something like this. Finally, we're going to connect all these together with a curve going through the vertex and going towards and near the asymptotes on the sides. So that's it. All right, so let's look at one more of these kind of examples. And this time we can see that the equation is going to give us a parabola. Note that there's no y squared term. So we'll start by completing the square once again. So we have x squared plus 10x, and 10 divided by 2 is 5, so we can add 25 plus 4y plus 13, and then of course if we added 25, we have to subtract its equivalent on the outside of the parentheses, so that will be just minus 25 in this case because the coefficient was just 1. Now we can complete the square. We can rewrite the first trinomial as x plus 5 squared. And we can also get to combine the like terms 13 and negative 25 to get negative 12 or minus 12. That's going to be equal to 0. Next, we're going to try to isolate y by itself. So 4y is going to be equal to negative x plus 5 squared plus 12 on the right-hand side. And of course, now we're going to divide both sides by 4. And we get y is equal to negative 1/4 x plus 5 all squared, and then plus 3. So this is an equation for a parabola in vertex form. So we can go ahead and identify the vertex in this case. That's going to be negative 5, 3. Okay, it is reflected over the x-axis due to this negative sign here. And finally, there's a vertical stretch by a quarter. So now we can go ahead and first start by labeling the vertex, so negative 5, 3. So right here. And then now we're going to find additional points using a table of values to graph on the grid. So there are points at negative 3, 2, and then negative 1, negative 1, and also 1, negative 6. Okay, so finally we're going to go ahead and connect these points with a smooth curve to form a parabola. And that's it. So once again, to recap, today we looked at the translations of conic sections, how to find the new centers, how to identify the horizontal and vertical stretches, and in the case of hyperbolas, also the asymptotes, and we are able to sketch them based on those that information. And then we look at how to transform general form back into center form, so we can graph those conic sections as well. And that's it. So once again, thank you for listening.